this section of the lecture. So the last chapter, I didn't talk about the shape of distribution. So going back to the idea of distribution, right? Distribution is the shape of how the data is spread out. So how it's distributed, right? Now, these are basically frequency distribution. So think about your frequency distribution chart, your bar graph, your pie chart, etc. In this case, this is the shape of the distribution. You have your symmetrical distribution, your negatively skewed distribution, or your positively skewed. So if you look at them in this case, your mean, median, and mode, this is when it's a unimodal, so like the next slide right here, in unimodal distributions, when the mode, the median, and the mean coincide or are almost identical, the distribution is symmetrical. So if they're almost identical, the distribution is symmetrical. You can see it's the same on both sides. Now, if the mean, is lower than the median, so you see the medians right here. If it's lower than the median on the left side, it's negatively. If its mean is on the right side of the median or above the median, it's positively skewed. So being able to look at these, right, seeing this right here as negatively skewed and this one here as positively skewed is important to be able to identify and recognize. Now, I just wanted to touch upon that because you need to be able to look at those to be able to articulate what that means. Now, for this, we're going to cover variability, and I'm going to talk a little bit about what it is, how it works, and why we measure variability when we have our measures of central tendency. So the measures of central tendency are important because they tell us our mean, median, and mode, right? Where is the data kind of situated? Where is the quartiles? Where is the median? Or where's the mode, right? What's the most occurring one? What's the average? All of those things. And that's important. But what can happen is that it can cause a couple of errors and hiccups, and we'll talk about that a little bit more. But the types of variability that exist are the index of qualitative variation, range, interquartile range, standard deviation, and variance. In this first video, we're going to cover primarily the index of qualitative variation. Now, why are we doing this? What is variability? So variability is basically looking at diversity. You're looking at how diverse is the group of whatever it is I'm measuring. Like, is it diverse? And we're in social statistics, so we're looking at people, right? We're looking at the social situation, and we're trying to understand basically the lived experiences and the differences that are going on. What can happen if we don't think about variability and we only use the measures of central tendency is that we can end up engaging in stereotyping. Essentially, we can ignore the diversity of the lived experience. The measures of central tendency are important, but if it says that, most people really don't really like, let's say it's like we have a class and really a lot of people really like it, but it only has one group of students. Well, if that's the case, that's not actually variable. It's not looking at diversity, right? That may be true. The measures of central tendency might highlight that. But if the variability shows that it's not very diverse, then it's really not as influential as we think it is. So the first thing that we're covering is this index of qualitative variation. And it is for nominal values or variables. So remember that ordinal are things that are in order, right? They're both categories. Nominal and ordinal are both categories, but nominal are ones that do not have an order while ordinal are. So for example, freshman, sophomore, junior, senior, that's an ordinal set of variables because they're categories in order, but nominal variables are things that don't have an order. Gender, race, ethnicity, religion, language, music genres, movie genres, things like that. Those are all nominal variables. Now, the range for the IQV, or the index of qualitative variation, is 0 to 1. And 0 meaning that there is no diversity, with 1 being super diverse. And so it is a range. You can multiply it by 100 as well. We'll go here. You can multiply it by 100 as well. Which gives you a percentage, and it's relative to the maximum possibility. So what possibilities are there? But for the purpose of this, we're going to look at it in terms of a proportion with just the decimal for now. Now this formula is a little scarier than it needs to look. And so what it is you have to create a percentage distribution. So we created frequency distribution tables and then converted those over to percentages. So you need to create that. Page 97 has a breakdown of that. And then you square them. So remember that it's like you multiply it by itself, right? If it's squared, you multiply that number by itself. So you have it twice. So in that case, you're squaring the percentages. You add those squared values up, and then you use this formula. So K is the number of categories. So if you had ethnicity, for instance, and there were 5 categories, so you could choose from, 5 is what would go in the K. This is your percentages of all of the individual categories squared and summed up, and then you plug in the values here. Page 97 has a really great breakdown for you around Maine and Hawaii, and we'll go over that in class too. Now, if we're looking at this, it's really important that we're understanding, though, that statistics can change over time, right? So that IQV for one state might be very different. Like, so the IQV for an ethnicity or racial group in California would be very different 40 years ago than it would be today, or even in the United States. And so understanding how these things can influence, how diversity in our society can influence our statistical practice is important. The United States, it says minority majority nation, but basically the United States, the demographic and population is changing. And if we want to be representative in our statistical practice, we have to be representative of that population as well, or the recognition of that, to be able to have a good solid variability to recognize that it's more representative. Things about geographic concentrations of groups as well. So like what's impacting that group region, making sure that whatever your purpose is, that you're including different people. And in this case, it can also talk about, IQV can also talk about diversity in different ranges. We could look at IQV in San Diego. We could look at IQV in National City, in La Jolla, in Claremont. We could look at the IQV in different regions as well as the larger. So it really does have an important role in terms of the social interactions and statistics involved. Now, the range is another form of variability, and I'll cover that in the next video. So we're going to talk about the interquartile range. So there's a couple things. We can't use range. It can be misleading, but another thing is that we can't use range for nominal variables really either. It can be used to describe diversity in like ordinal variables because they're in order, but nominal variables don't really have there's no real significance to them if it's just a matter of random scores. We can do it for ordinal variables, but we can't really do it for nominal variables. Nominal variables are important for understanding like demographics and descriptions of things, and the breakdown, but we can't really do it in terms of nominal values. The range also is limited because it really shows the extremes. It can show the extremes of things, which is why it doesn't really give us full information about the variation. It can give us like a range, which shows that it's a large range, of course. But again, that range doesn't necessarily give us a whole lot because it really is just the differences between the highest and maximum, then lowest. And there may only be one score in those that are these extremes. So understanding that there's a lot of limits to the range is important. But moving forward, there's a lot of ways to also figure out the variability within that range or your data set. So one way that we tackle that, we kind of address that, is this interquartile range. So the range is important, but it's limited for a couple of reasons. The first being that you can't use it for nominal variables. Excuse me. So one thing that we do is we can use the interquartile range. So the interquartile range is basically, it's a measure of variation still. It's variability. And you can use it for like the interval, ratio, or ordinal variables because there's some sort of order. We use it. This is where you can understand like the median, right? Which is the 50%. we understand and we're familiar with how to calculate the median. You use it with ordinal, interval, or ratio variables, etc. And that shows us our 50th percentile essentially. But now, in order to identify the interquartile range, we're using a little bit of different calculations, and you essentially are going to find the 25th percentile and the 75th percentile. And not just finding the percentiles, but then you use that in order to identify your interquartile range. So the interquartile range shows you what the range is between the 25th and 75th percentile, which gives us a little bit more information about the variation and the variability, because it shows you more of the range and differences between the 25th and 50th percentile, or you can, right, and the 75th and 75th and 25th percentile. So if you look at page 101 to 103, it gives you kind of a breakdown of this. And essentially all you're doing for the calculations of this is n times 0.25 in order to find your 25th percentile, and n times 7.75 to find your 75th percentile. And this is important because the n is the number of cases, right? So if you had 20 cases, 0.25, that's what you figure out. Then you same thing, 20 times 0.75. That gives you your 25th and 75th percentile. Then what you do is you subtract your lowest number, which is from your highest number, which is similar to the range in that way, right? And what you're doing is you take your quarter 3, which is n times 0.75, minus quarter 1, which is n.25. And that is going to give you your interquartile range. So that way it helps what your IQR is. Now you can, and sometimes it's important to report the full IQR, which basically, instead of like subtracting it, you would just basically put on there that number that is Q3 and the dash with the Q1, because it shows the whole range instead of just the percentage or just the value. So that gives you more meaning in terms of the range and the value, instead of just saying, oh, it's this many points, which then gives you a percentage. It shows the whole range. So very similar to the range before. So, we'll practice this in class a little bit. It shouldn't be with interval and ratio values and ordinal values. This is where the interquartile range is important. Okay, so now we're shifting gears into the box plot. It's not really shifting too many gears, but it is in that it's visual. So we've talked about the visual representation and graphic representation of data. And in this case, the box plot is basically something where you can plot you can see the range, you can see the IQR, you can see the median. So basically, your lowest score and your highest score, as well as the IQR. So it's a visual representation of those things. It allows us to be able to see the distribution across the 25th quartile, the 75th quartile, etc. It also gives us that shape of distribution that I talked about at the beginning of the slides. So basically what it allows us to do is to be able to visually understand the distribution of data, instead of just having the numbers on the page. Like, the numbers can give us a lot of insight, of course, but the visuals basically allow us to see these things in a different way. And we are going to practice making box plots. I'm not asking you that you necessarily include it in your case study, but I do want you to at least know what a box plot is and to look at it. So what you do is you basically draw a box, and you draw a box between the lower and upper quartiles, and then you draw a line with the box to mark the median. So you have to be able to understand the median and all of these other things. Then you draw the vertical lines, which are called whiskers, outside of the box that extend to the lowest and highest values. So it's a square with a line up and down, and the box is basically where you show the range of Q-1, and then you have the whiskers or the lines that go up to show the difference between the lowest and highest values in the range. And what it does is it visually shows you that range, and then what the difference is with the interquartile range. It shows you that. And then it shows you what the extremes are, basically, or the other values. And what it does is it gives us like a visual impression of what the data looks like and how the data is spread across everything, how it's spread, how it's skewed. Being able to explain how it's skewed is also important. A perfect distribution, symmetrical distribution, would have the box right at the center of the range. But if it's not, if it's not centered, if it's lower to the if it's closer to the lower quartile, or the higher quartile, that's what you should be looking at, is which direction is it skewed. Because it allows you to see what the shape is. And if you think about that distribution, it helps you understand which way things are kind of leaning and where the bulk of your data is. So that's all super important, especially as we start moving into variance and standard deviation. Standard deviation is one of the kind of go-to methods and methods of measuring variability, and it is one of the ones that you should be familiar with. So we are going to talk a little bit more about this in class, and make sure that you are kind of following along with this as we move forward. Okay, so we left off at a box plot, and the box plot is really important because it's a visual representation of the data. It helps you see the measures of central tendency, specifically the median, and it gives you a visual representation of variation and variability because you're able to see the differences in the diversity based off of the whiskers of the box plot, and how it relates to the rectangle, which really is that kind of central component. That allows us to really be able to see a visual representation of the variability within the data. But now the thing is that this interquartile range, though, is not the only measure of variability that we have. So far what we've covered is the index for qualitative variation, range, just like your general foundational range, and then your interquartile range. We've also talked about the box plot briefly, which really incorporates the visual representation of that interquartile range, so we can see the values and variation within those. Now, what we're going to be covering next, is variance and standard deviation. So essentially what this is this allows us to see an overall variation across the distribution. So we have these different things, right, that we've talked about already. But what the variance does is it's basically an average of the squared deviations. And the deviations are like things that deviate, that are different than the norm, right? And in this case, we have our mean, which is at reference point. So our mean is that average, is the mean of what's happening. And that is our reference point from here on out with variance and standard deviation, because what the mean is, right, is that average responses or the average understanding of things. And it's important so that way we can have an idea of whether or not things are going to change, what the averages are. We can also compare averages across different areas. So if we're looking at it from like a national perspective, maybe we want to look at mean income across all the states compared to the federal level. So these are all the things that we're going to think about in terms of variation. It really allows us to see like the changes, and what the deviations, or so the term deviate being a change, how that's going to happen. So essentially, before we get to that, essentially what the variance is basically it's variation for interval ratio and ordinal variables. So we talked about this, right, that how like you can't really do these things for nominal variables because you are assigning arbitrary meanings to them, but we can do it for interval ratio as well as ordinal variables and variables and values. And so the variance is looking at a measure of this variation basically across it. And what it is it's an average of the squared deviations from the mean. And if we're looking at it, excuse me, it is important that we're understanding basically this distribution. How much does it change or deviate from the central point? So maybe at this point, you can kind of see how things are kind of coming together. At the very beginning, we understood the difference between independent and dependent variables, right? Because we want to know what the subject or the topic is of our research. We started talking about measures of central tendency, which is really important because this is where the standard deviation comes in, because we need to know what that measurement of that central point is, that central point or the data, which is specifically the mean in this case. So we're using the mean as a reference point right now. Not so much as an average in the same way. We're not looking at mode and median, but we're using the mean because it's based on all of the scores in the distribution and then averaging them, right? We're looking for that mean. And so that's why we use the mean, because it helps us calculate what the deviations are. So it is important though, because sometimes in these means, there can be extremes, right? There can be extreme values, which is why we have to look at some of the other measurements of variation. Another reason that we're using the mean is that it's a reference point, in that it uses a lot of algebra, and it allows us to kind of come up with some assumptions, so to speak, about things. And understanding deviations basically understands these changes from that central point. So the variance in this case, in terms of calculation, is just the average of the squared deviations from the center of the mean. And then the standard deviation is the square root of the variance. So you basically take all those variances. Like the variance is basically you take those deviations from the mean and you square them and you find the average. Meanwhile, the standard deviation is the square root of the variance. That they're doing is that they're both measuring this variability or these differences within your interval ratio and ordinal variables. This set of lecture notes, I really just want to kind of cover it conceptually because there are going to be some math components in the next set, and I want to make sure that we have an understanding of them. But remember, right, how we're calculating the mean. Remember that process, because understanding that process is going to be important. We've already started diving into some of the calculations like the IQV, which is the index for qualitative variation, as well as the interquartile range. So having those understandings of variability is important. But IQV, which is only for nominal variables, right? At this point now, we need to have something that can have some sort of statistical value, which is why it has to be ordinal, or it has to be interval ratio, because it needs to be able to have some sort of logical sense of order. So in this case, when we're looking at deviations from the mean are basically the differences. It's looking at the differences between what's going on in the data and the mean. In this case, this difference that we're talking about is specifically called a deviation, or a deviation from the mean. And it is symbolized as the y minus y bar. So just y minus y bar. Remember, the y bar is that line above the y. In this case, the reason is that we're looking for what the mean is. Like what is the actual number that we have that value minus the mean. So we'll do this in practice in class. But essentially what you're looking at is each of the deviations from the mean is that y minus y bar. So whatever value you have minus the mean. Then when you sum them all up, you use that E, that sigma symbol. So it's sigma parentheses y minus y bar. And so this is where we're starting to calculate those deviations, because you're looking at this average deviation. This is the sum of the deviation. There can be positive and negative values, because if we're looking at it in terms of what to expect on like a if we were plotting them, for instance, on like an XY axis, it is important that we look at them, that there are possibilities for negative and positive values. So I'm going to stop this lecture slide here, because I really want you to grasp this right here. So this Y value right here is that value, whatever value you have within that category. So if we go back to a couple weeks ago where we talked about siblings, whatever your Y value is this minus your mean. Okay, so that's where we're at right now. And then that sum of deviations is a sigma times whatever is in here. So that's where we're at, right? It's the sum of deviations. So you're calculating everything up. This is the sum of these values. So whatever these are, you're adding them all up you're doing each of them individually and then adding them all up. That's what this represents here, is that combination, that sum of all of those. Okay, so continuing on with this, I just want to kind of talk about a couple of things. So basically, these differences, the y minus y bar, that is the deviation. And that difference is called the deviation. And this right here is how it's represented, how it's symbolized. And the sum of the deviations basically is what that is. This is what that represents, is that sum of those deviations. And so it can be positive or negative values. This deviation is positive when the percentage change is above the mean. So that's why those negative and positive values are important. So the number itself may not be negative in the big picture, like the y may not be negative, but the deviation may be negative. And what that means is if it's negative, it's below the mean. If it's positive, it's above the mean. So that's really important when we're thinking about how to understand and articulate these things. And so when we're looking at it, the mean is the center of gravity for this distribution, right? So that, again, go into that idea of central tendency. That's what the mean is. It's that central gravity point, that central point in the distribution. If we were to subtract the mean from each of the scores and then add up the deviations, the sum would be 0, because the average deviation it causes the average deviation to compute to 0. So one way for us to overcome that problem of those zeros is by squaring the deviation. So the deviation times itself, and it gets rid of the negative sign. So that is important when we're thinking about it for like mathematically, if we're understanding it in terms of the calculations. But just remember for now, like ultimately, these are the two really important things just to think about for now. But those absolute values, absolute zeros, can be difficult to work with mathematically. So when we square them, that's how it makes it a little easier to mathematically work through. But that's important to think about as we're moving forward. Okay, so looking at it, right, if we look at this here, this is where we're actually starting to calculate things. So understanding how the calculations of the deviations from the mean are here is important. But now moving forward, when we calculate variance and standard deviation, this is how this is. So when we're calculating variance, we use n minus 1 instead of just n. So remember, n is the number of cases or responses, right? So when we're calculating the variation, this is the formula that we're working with here. So it's the sum of the deviations right here squared. And that's where we represent that. That's how that is. So that right there, understanding this, how like the square of the actual deviations and the mean and added together of the squares, the sum of squared deviations is symbolized by this. So when we're squaring them, it's representing the deviation from the mean as a positive, so we can mathematically calculate it easier. Oops. Okay. So when we're looking at this now, we're using n minus 1 in calculating the variance because we're interested in the average of the squared deviations from the mean. So what we need to do is we need to divide the sum of the squared deviations right here by looking at the scores of n in the distribution. But unlike the calculations of the mean, we're going to be using just n minus 1 in the denominator right here. So n minus 1. So understanding this formula is really important. So we have our s squared, which is the standard deviation. Well, this is the calculation that we're going to do for it, equals the sum of y minus y bar squared divided by n minus 1. Okay, so when we're looking at this, this s squared is the variance. It's the deviance in the mean. It's the sum of the squared deviations in the mean, and then n is the number of scores, right? So when we're looking at this, we're going to start thinking about this in terms of like our numbers that we have. So in order to calculate Okay, sorry. This is where this is just kind of an overview of this. This is the formula that you're going to want to look at and hold on to. So here's the actual steps, basically. So what you're going to do is you're going to calculate your y bar, which is how we're calculating the mean, right? You have the sum of all of y divided by n. Then to find the deviations, you're going to have y minus y bar for each of those values. That's something that you have to do, is each of those values. Then you square each deviation. So this is where you have your y value minus your mean squared. Okay, so that's the first step that you're doing. From there, you're going to sum these squared deviations that you have. So, right, remember, we've gone through the mean, we've subtracted the mean from each of the scores, and then we are squaring each of the deviations. Now, at this point, you're adding all the squared deviations up, right? So you're starting to add them up. Then you divide it by this n minus 1. So this is what this would look like right here, is that sum value that you have divided by n minus 1. That answer that it gives you is the variance. So basically following this right here is what will give you the variance. Okay. Now that variance is important though, because it's not expressed in the original units of measurement. Going back, sorry for the flipping between, but going back to this, understanding that it's harder to work with things mathematically when you have those absolute zeros and the negatives and the absolutes. That's why we square them. That's why we're squaring it for now, simply for the mathematical purposes. So now that it's not in its original values, the variance isn't going to be expressed in its original measurement. That's why now you are going to take the square root of that number. That square root will give you your standard deviation. So now your standard deviation is the square root of that. So whatever you got here for your variation, whatever you got through here for your variation, or your variance, my bad, variance, is what you're going to be square rooting of. Now it is now the same units as the original data. And it now is the standard where you can understand what the score is, negative or positive, what relationship it is to the mean. Okay, so understanding that, it might be a little complicated now. When we start practicing it, hopefully it'll make more sense. But how are you going to choose? What are you going to choose now? Right, we've talked about the index for qualitative variation, range, interquartile range. We've talked about variance and standard deviation. And so what are you going to choose? How are you going to choose which level, like which measure of variation are you going to choose? So this little table here is super useful. If it is a nominal value, you're going to choose this IQV, right? Because it's really helping you understand diversity and variability in that distribution. Now, it's helpful. Now, that's why understanding the levels of measurement are so important, because this table here helps you understand which option you're going to choose. So if it's ordinal, right? Remember, it's categorical, but it has an order to it. Think about what that ordinal value is as it relates to the research objective. What is the purpose? Sorry. If it's to measure the variability, but you're not necessarily thinking about the rank order, you can also use IQV for that, right? You're just trying to look at diversity, but you don't care about what order the rank is. You can use IQV, and you will often use IQV. If your idea is to understand just the variability in the distribution, that may include that rank order, variance and standard deviation will be important. And that's why the assigning the values and the measures of central tendency were so important. If you're going to think about how you're going to measure the range of the ranked ordered categories, so thinking about that median, right, 50%, 25%, 75%, etc., you're going to use your range and IQR. So you need the range to figure out the interquartile range. If you have interval ratio values and data, you need to think about the shape of the distribution. So is the shape of the distribution symmetrical, or is it not? If it's not, you're going to look at the range and the IQR. If it is symmetrical, you're going to think about the variability as it relates to also range and IQR, and then also your variance and standard deviation. So understanding the levels of measurement, nominal, ordinal, interval ratio, how it relates to what your research objective is, the shape of the distribution, those things are going to be things that you're going to want to start practicing as you move forward with your case studies. And then lastly, really thinking about some additional steps. So understanding the levels of measurement, nominal, ordinal, interval, ratio, understanding which measure of central tendency are you going to use, mode, median, mean, and then what types of variations are you going to calculate, right? And so these are all important things to consider as you move forward with your case studies and any additional calculations.